Hi, I'm Mr. C, the teacher, and this is my classroom. Over the years, I've created hundreds of lessons in every subject area. That's tons of topics to teach. So grab your tools for school and join in with us. Or sit back and just watch. And let's go on a learning journey together. Because you're watching Lessons from the Classroom. Well, let's take a look at what the topic for today's episode is going to be about.
A rubber ducky, you're the one. A rubber ducky is so much fun.
Hey guys. Today we're going to be talking about floating. Floating and sinking, which we also call buoyancy, when we're talking about whether something can float or sink. I'll take my rubber ducky out though now.
Love you, rubber ducky.
Hi, I'm Mr. C, the teacher, and this is the Dead Sea in Jordan, in the Middle East. In this episode of Lessons from the Classroom, we are going to be learning about buoyancy.
Doesn't that mean the same thing as floating?
Buoyancy means the same thing as floating.
Oh yeah, that's what I just said.
So why the Dead Sea? Because the Dead Sea is 190 meters below sea level. And it's 13 times saltier than any other sea or ocean in the world. And that makes things float. Now, what I've got here are two identical tanks filled to exactly the same height, both with fresh water. And we're going to take two identical containers and fill them with the exact same amount of sand and float them. But one of these tanks, I'm going to add sea salt to it. Theoretically, salty water makes items more buoyant, which means the container that's in the salty water will be floating higher up in the water, like the Dead Sea where I went to float. You can see on the rocks just how salty it is. Let's give the experiment a try and see if it actually works. Both containers now have the same amount of sand in them. If I float them really carefully, put it in the water gently, go gentle, we can see it floating. And I can use a felt marker to very carefully mark where the water line's at. Large ships in the ocean have lines painted on their hulls so that they can see where the water level's at. All right, this one is floating in fresh water. And in this tank, we've added plenty of salt. We'll stir it up to try and dissolve some of the salt into the water, just like in an ocean. All right, let's add our second container with the same amount of sand as that into our salty water and see what happens. Let's draw our line for where the water is. This one appears to be bobbing around a lot easier. It's actually pretty hard to even sink. Whereas this one tends to go to one side. Well, bob's pretty good as well. You can certainly tell the difference in the color of the water. Water full of salt and clear fresh water. Water we can drink and water that we can't. But which one is going to be more buoyant? Will it make any difference at all? Or do we need a lot more salt to really make a true difference. Let's pull out our containers and see if the marks are higher on this one or higher on that one. All right, so when I compare my two water lines, I can see this one that was in the fresh water, the line is just below this rim. It's quite high. This container sunk down quite a bit. Whereas the line on this one is a bit lower. This container was held up above the water level higher. This one was in the salty water. This one was in the fresh water. They both are the same container with the same amount of sand in them. And this one floated better because it was in salty water. Salty water makes things more buoyant. All right, it's the time in our show when we have a segment I like to call Questionable Letters. And that's where a viewer writes in to ask us something. Let's see what today's letter is going to ask.
Questionable letters!
Well, let's see who our letter is from today. It says, Dear Mr. C, is there a kind of rock that can float? From Bob N. Boye. Well, Bob, thank you very much for your letter, and that's a great question. Now, probably the first answer most people will say is, no, of course not. Rocks sink. I throw rocks in the ocean and the lake all the time. I can skip them, but they always sink. Well, let me show you one special rock that actually floats. Well, Bob's question is really great for conducting a science experiment. Here we've got two very different rocks. This one's called a conglomerate. It's made up of lots of other little rocks stuck in together. And this is a piece of pumice. It's a volcanic rock. Let's find out what happens. The pumice floats.
Slow motion moment.
Worksheet lessons.
So here we have a worksheet hands-on experiment to do with our theme unit on matter. And we're looking at, with matter, some forms of matter, whether it has the ability to sink or float, whether it's buoyant, meaning it can stay afloat. So it says here for the summary, we're going to use free play and directed challenges to explore concepts of sinking and floating. So we're going to have a bunch of materials, a bucket of water, and then lots of different things that we can put into that container of water. So here's some of the objects that we're going to put into our water container to see whether they sink or float. We've got a pencil, a crayon, a marble, a screw or nail, toy car, a styrofoam ball, a wooden block and another longer piece of wood, a piece of Lego, an empty tin pop can, a little plastic boat, some scrumpled up paper, a rock, and a sponge. And we'll test each one of those out to see whether they're going to sink to the bottom of our container or float. We're going to use a big silver container like this that we'll put water into. If you were to have something like a fish tank or a big glass bowl that you could see through the sides, that would probably be even better. But for our purposes, we're going to use this big tin foil container. It's waterproof, so the water won't leak out of it. And on the back side of this worksheet, it says draw objects that are floating or that have sunk to the bottom. Here we can see the water's on top, and here's our container. And it's going to ask us, what did we observe? So let's do our experiment first. So here is our container of water. So let's try a little plastic boat. Let's see if that'll float. Oh, look at that. There it is on top of the surface, floating around, doing what it's meant to do, which is to be a little boat floating. Well, let's try out our nail or screw and see whether they sink or float. Here we go. Oh, straight to the bottom. They both sunk. And we've got our empty pop can. So this one's empty, which means there's air inside of this can right now. Let's see if it sinks or floats. Oh, it's floating. What happens if I were to remove the air by filling it with water? So the water will take over where the air was. So now the tin can is full of water. The air's been removed, or most of it. It's quite a bit heavier in weight. Is it going to sink or float? Still floating a little bit. Not as much though. So the water is making it a little less buoyant. What if we try a crumpled up piece of paper? Will it float or sink? What do you think is going to happen? Well, look at that. It's floating. There we go. It's floating on the surface. Let's try a rock. What do you think is going to happen? Float or sink? Oh, straight to the bottom. It's down to the bottom. It is a sinker. Let's try a toy car. Will it float or sink? Oh, straight down to the bottom. It's a sinker. How about this sponge? Will it float or sink? Oh, it's floating right now. What if I got it wet completely? Will it float or will it sink? Even wet, it's still floating. Here I have a block of wood, and here I have a thinner, longer piece of wood. Will they both float, both sink? What's going to happen? Oh, look at that. This wood is buoyant. They're both floating. Here I have a pencil. Float or sink? Oh, it's going to float. Here I have a crayon. Will it float or sink? Ah, it's a sinker. Went straight to the bottom. How about a marble? Will it float or sink? Straight to the bottom and really fast. It's a sinker. What about a piece of Lego? Float or sink? It's going to float. And what about this styrofoam ball? Float or sink? Styrofoam's very light, so it floats right to the top easily. Can I make it sink? Let's push it down. Oh, right back up it goes. It won't stay down. Okay, we're also going to try one other experiment. In this case, we're going to use a piece of tin foil, and we're going to use a piece of modeling clay. I've taken a piece off already. What I want to do is I want to find out, is this modeling clay, is it going to float or sink? Oh, sunk straight to the bottom. What about this piece of tin foil? Let's just hold it a little smaller. Is this piece of tin foil going to sink or float? Oh, it's going to float. If I put the piece of modeling clay on top, oh, I can get it to hold that modeling clay up. In fact, I could probably even build myself a little boat. There we go. Now I've got a little boat. I can put my modeling clay in, get it to try and float. I need a flatter bottom on this boat. There we go. So something that would sink can now float. What if I took the piece of tin foil and I pushed it into a really tight ball? Will that sink or float? Oh, look at that. It still seems to float. So we can see all of our different items that float, some of our items that sink. what we could say that we've learned about floating and sinking is that heavy objects that are very dense, there's no air in here, it's very solid and it's heavy, like the marble, it's going to sink. Same with this toy car, right? It's heavy, it's going to sink. And this crayon, it's also heavy and it's sunk. Whereas things that were lighter weight and spread out, like this piece of wood, floated. Or things that had air trapped inside them. There's lots of little air bubbles inside this sponge, and it's very lightweight. And there's lots of air inside this can. Even a little air inside this can will cause it to float. And the same kind of happens with the scrunched up piece of paper or the scrunched up tin foil, is that because there's lots of air trapped in between all these spaces, and because it's light in weight, it floats. So we can say that light things float, heavy things sink, but also if light things have air trapped in them, they can also float. Alright, so taking a look at our worksheet, let's draw some of those objects. Let's think of some of the ones that floated. There was the long piece of wood that floated. It was pretty thin. There was the block of wood that floated, although it sort of floated on its side, didn't it? There was the big styrofoam ball. That one floated. There was the sponge. That one floated. What thing sort of sunk though? Well, we had the rock. That sunk. And we had the toy car. That one sunk. And we had the round marble. That one sunk. And we had the crayon. That one sunk. Whereas the pencil, it floated. And the little piece of Lego, that floated. And the crumpled up piece of paper, well, that one floated as well. Although I wonder what would happen if that paper got wet, and the wetter it got, whether it would sink. Those are some of the objects that we tested out. Add a little color. So we can say, what did we observe? What did we see? I guess we could say we saw that heavier objects sunk and lighter objects floated. So let's write that in. Heavy objects sink. Light objects or things float. And there we go. That's our lesson on objects that float and sink. All right, it's time in our episode for this segment that I like to call the Did You Know Fun Facts.
Did you know?
Did you know that the largest iceberg in the world is named A23A? and it's nearly 3 times the size of New York City. It happens to be about 400 meters thick and about 4,000 square kilometers in area. That's huge. Smaller bits of iceberg are known as bergy bits and growlers. And bergy bits and growlers, they can originate from ice shelves or from glaciers, or they may be the result of a larger iceberg that's just broken up into little bits. Did you know the largest ship ever built is the Sea-Wise Giant? It was also once known as the Knock Nevis. It's an oil tanker that happens to be 458 meters long and 70 meters wide, and was used to carry oil from 1979 to 2010. But the largest human-made thing that floats, unfortunately, plastic pieces that have gathered together because of ocean currents. And there's more than one located in the different oceans within the world. There's a particular one here in the Pacific Ocean known as the Great Pacific Garbage Patch, and it's about the size of Alaska. It's made up of at least 79,000 tons of garbage, mainly plastic. The plastic litter dates all the way back to the 1960s, and a big part of that patch actually lies underwater. It was formed by ocean currents, and as I said before, it's not the only one in the world. So why don't they clean up the Great Pacific Garbage Patch? Well, first of all, because it's made up of tiny, tiny microplastic bits that can't be easily removed from the ocean, but also because of just the enormous size of the area. Some calculations were done, and to clean up just 1% of that great garbage patch, it would take 67 ships an entire year. And that's just to clean up 1%. So I guess 100 years of 67 ships going non-stop, assuming that we don't ever make any more plastic that ends up in the ocean. And unfortunately, those microplastics are getting so small that now fish are eating them, and we in turn are eating those fish. And we're finding microplastics now in all sorts of animals as well as us humans. And those are some of the largest things floating in our oceans.
Now you know.
All right, well, it looks like I've got plenty of art supplies and tools on hand, so I guess it's time to do some quick art creations.
Quick art creations.
Well, that's all the time we have for today's episode. I'm going to finish off by doing the old apple versus pear buoyancy test. You see, according to scientific thought, apples should float. I mean, bobbing for apples at Halloween time, right? Whereas pears should sink.
According to science, this is why apples float and pears sink. The low gas content of the pear can't compensate for the weight of the rest of the fruit, so down it goes.
Well, that's kind of weird because they're both very similar fruits. They both grow on a very similar type of tree. Weigh about the same, and well, their shape it's a little different, of course. And in fact, apples and pears, well, they're kind of related. Think of them as, like, cousins.
Hey, cuz, let's make like a tree and leave. You may be a pear, and we may be cousins, but you're not an apple, and nobody would bob for you. Yes.
Oh, that was weird.
Well, let's give the old buoyancy test a try right now. Well, after repeatedly trying, we can see that they both float. So even though the pear sinks to the bottom right away, it does float back up. Whereas the apple, it floats right from the beginning. So the old scientific thought that apples float but pears sink is not true, and we've just proved it here. And that's what science is about, proving through experimentation. Cool.
Oh, yeah, kind of really makes you think, doesn't it?
All right, see you next time. Well, thanks for joining me, and I hope you learned something new and had fun doing the lessons. Join me next time on another episode of Lessons from the Classroom.